In today's video we'll be studying about Boole's inequality, that is this inequality. So Boole's inequality states that the probability of union of the events will be always less than equal to the summation of the probability of the individual events. So let us just break this down. So this essentially means that probability of A1 union A2 union up till union AN is less than equal to P of A1 plus P of A2, the summation P of AN. This is just complex notations, but it simply means this thing. So let's begin the proof. So let us say we take n equal to 2. In that case, what will it become? Before that, let us just write the theorem of total probability, that is P of A1 union A2 is equal to P of A1 plus P of A2 minus P of A1 intersection A2. Now we can write this in a different way. So just remember this. Let's just call it star. Now it's quite obvious that P of A1 plus P of A2 minus P of A1 intersection A2 would be less than equal to P of A1 plus P of A2. And this is quite obvious because this quantity is greater than equal to 0. So something positive is getting deducted from another positive quantity. So obviously this inequality holds obviously true. So, and this one is nothing but from the above the theorem of total probability, we can write it as P of A1 union A2 less than equal to P of A1 plus P of A2. Okay, so we have proved for n equal to 2 that this thing holds. Now let's just extend this thing. Let's just take n equal to 3. N equal to 3. So it becomes P of A1 union A2 union A3. Now I can divide this thing as like this. Let me just write it at the bottom. P of A1 union A2 union A3. That is, I am defining this one as one event and this one as another event. So there are two events. So let's say this thing is just a event B1. So if I just name this as B1, then B1 and A3 are like it becomes P of B1 union A3. And we know for n equal to 2 the Boole's inequality holds. So let's just remove this because it overcomplicates the things. So we can write this as, we know that this thing is obviously less than equal to P of A1 union A2 plus P of A3. Now this part can be further written as less than equal to P of A1 plus P of A2. Then this entire thing now can be written as, obviously this is further less than equal to P of A1 plus P of A2 plus P of A3. So we are seeing that this this thing is obviously less than equal to this thing. So we can write it P of A1 union A2 union A3 is less than equal to P of A1 plus P of A2 plus P of A3. That is Boole's inequality holds for n equal to 3 as well. Now let's use the method of mathematical induction. That way it would be easier to understand. Okay, so we assume that it is true, the Boole's inequality holds. Boole's inequality holds for n equal to m. Assume. Using this, if we could prove that it also holds for n equal to m plus 1, we are good. That is, the proof is done. This is the method of mathematical induction. So let us just write it down. P of union of I is equal to 1 to m ai less than equal to summation I is equal to 1 to m probability of ai. Let's just define this one as some equation 1 and this one as equation 2. Now let's take n equal to m plus 1. So what it becomes? P of union of I is equal to 1 to m plus 1 ai. I can simply write it down as P of union of I is equal to 1 to m ai union am plus 1. I'm just breaking the thing. Let's just use third brackets for clarity. Yeah. So what did I just do here? I just did nothing. So A1 union A2 union AN union AM plus 1. I just put a bracket at these two locations. I define this as one event B1 and this as another event B2, just like that. So to make it simple, let's just write it in that way only. So this is nothing but P of B1 union B2, and we have already established the fact that for n equal to 2, which in this case B1 and B2, the two events, the Boole's inequality holds. So it becomes P of B1 plus P of B2. Now let's just write the two things. So now the thing becomes P of union of I is equal to 1 to m plus 1 ai less than equal to P of, let's just fill the places. B1 is nothing but this thing, and B2 is nothing but this thing. The probability of union of I is equal to 1 to m ai plus probability of a m plus 1. It's pretty simple. Now this thing alone is less than equal to P of not P of, it's less than equal to summation. Okay, I don't have space here, I'll write it down. This thing alone is less than equal to summation I is equal to 1 to m P of ai from 1. Yeah, so we are using this one. Okay, so it's not 1, it's actually 2. So we can ultimately write it as, which means it would be further less than this value. So it would be further less than summation I is equal to 1 to m P of ai plus P of am plus 1, which is nothing but summation I is equal to 1 to m plus 1 p of ai. So we established the fact that probability of union I is equal to 1 to m plus 1 ai is less than equal to summation I is equal to 1 to m plus 1 p of ai, and thus we proved that it also holds for n equal to m plus 1. Hence, by mathematical induction, the inequality is proved. In the next video, we will be discussing Born-Ferroni's inequality. Till then, like this video and do share it with your friends and subscribe, as it motivates me to bring up such content.